Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good day, everyone. Okay, we met again on the online learning for the second week. Okay, for the first week, I believe that you must be aware, from the exercise and from the notes, that the difference of different craft and charts, right, available. So, from that, you can know basically statistic involve describing everything through the usage of charts and graphs. But the thing is, the data is not going to be beneficial if, let's say, it is not interpreted in a numerical representation. So we move forward for the second week, which is on the this numerical calculation. Okay, let's move on. Okay, the first thing first, graph. As I mentioned earlier, graph and charts are effective at giving the overall view of a situation, because basically you can see the trends and the thing. The trends and the dynamics and everything, whether it's going to be increase or fluctuate or stagnant. However, graph and charts cannot give precise information for the inferential purposes. Mean to say, in this case, to make conclusion. So graph and charts alone are unable to give conclusions, or to go or to give or to deliver conclusive information about the data. Thus, we have to add the numerical representation to the graph. Okay, there are four main criteria for the numerical data representation. The first thing is mode. What is mode? Mode is the value that appears most often in a set of data. Okay, let's say 5 always appears, so the mode is 5. So, alright. So, mean to say that the same value that appears the most in the one set of data. And next is range. Range is the difference between the lowest value, for example, 1, and the highest value, and for example, 9. Okay, 9 minus 1, this is going to be 8, right? So that is the range. And next up is the median. So the median is the middle number in the list of numbers ordered from lowest to highest. So we mean to say that if, let's say, you arrange a number, and then what is in the middle number, so that is median, as the name suggests. And last one is mean. Mean is the total of all the numbers divided by number of value. It is something like average, but the difference is, for example, like we have one set. It depends on the number of values that is involved. All right. Okay, next up is measures of center. Okay, measure of center is a measure along the horizontal axis, right, of the data distribution that locates the center of the distribution. So in this case, we have to know what is the measures of the center. So it can be defined by mean. It can also defined by median. It can also be defined by mode. Okay, for example, right, we can see here from this list of data, how do you decide, or how do you use this as the measure of the center? Okay, for example, the mean here from the data is 38.76316. Right, okay, this one. In the meantime, the median is 39.5. It's much higher, and the mode is 40. Okay, now we have to identify the different definition. How do you define the measure of center? Okay, next up is we have extreme values. Okay, the mean is more likely affected by extremely large or small values than the median, and the median is often used as a measure of center when the distribution is skewed. Okay, so from this data, the mean is 10.97. Actually, it should be here. Sorry, and the median is 6, and this is the extreme value. Okay. Okay, looking at this data, mean is often used as a measure of center. Okay, when the distribution is symmetric. How it could be symmetric? Symmetric is when the mean is equals to medians, but it will be skewed. Median is often used as a measure of center when the distribution is skewed. Right? I mean to say that if it is skewed to the right, I mean to say that the mean is higher than the medians. Or it can also be skewed to the left. Okay, like this one skewed to the right, this one skewed to the left. So what is meant by skewed left is when the mean is lower than the medians. Okay, let's proceed to the exercise. Let's proceed to the exercise from the website. Okay, the first question is I want you to draw the frequency histogram and calculate the mean, median, and mode for the number of 5 kg of rice purchased by the following 30 households. So these are the value, and you have to arrange it according to the frequency histogram. And after that, calculate the mean, median, and mode for the data. Okay, after you have calculated it, record it somewhere else. Okay, next is because last time, yes, just now we mentioned about the skewed right? So proof the data is skewed as follow is skewed right. So you mean to say that you have to prove that the data should be skewed right? So what is meant to be? So according to these definitions, right, so I hope that you can understand that. So of course it's going to be involved mean and median. Play around with that. Okay, moving on to the next slide. The variance. The variance is the measure of variability that uses all the measurements, which is as opposed to range that uses only 2 measurements, which is maximum and minimum. It measures the average deviations of the measurement from their means, right? So this is the definition. The variance of a population is the average of the square deviations of the measurements about their means. Sorry. Okay, basically these are two important uh, ways to calculate variance. One of it is the population, and another is the variance of a sample. Through these definitions, it's the sum of the square deviations of the measurements about their means. So you have to sum up the x, the value of x minus the mean, and you make it squared and divided by the number of data minus 1. Okay, meanwhile, the standard deviation, in calculating the variance, we square all the deviation, and in doing so, change the scale of the measurement. To return this measure of variability to the original units of measure, we'll calculate the standard deviation, the positive root of the variance. Okay, so this is how you want, if that's the question, is about what is the population standard deviation. So this is the value because of the formula just now, right? And also this is the formula for sample standard deviations. Which is related to this value, to these units. Alright. Okay, some notes to notice. The values of S, sorry, this one's supposed to be S. The value of S is always positive, right? So the larger the value of S squared or S, the larger the variability of the data set. So this is the input that you have, you can take notes. And the question, there's something that we have to wonder, why divide by n minus 1? Because the sample standard deviation S is often used to estimate the population. Standard deviation as dividing by n minus 1 give us a better estimate of S. Alright, okay, let's move on to the next question. Calculate the sample variance of the data below. So there are 5, 12, 6, 8, 14. Okay, so now I want you to calculate and send the calculation through this link here. After you have calculated it, you can make it in the form of Excel. Yeah, preferably to be in Excel. And don't forget to click on the right answer. Okay, next question is, show another way to calculate sample variance. Just now I mentioned that there are two ways of calculating the variance, right? So show another one and upload to the same link too. Okay, from the data here, find the mean, median, and mode of 5, 7, 3, 5, 6, 8, 5, 6, 4, 6, 25. Okay, from the value, from this 4 value, just choose this one. You don't have to upload the calculations, so I give you sometimes. And given the observations 7, 9, 10, 6, 8, 7, 8, 9, 8, so I want you to calculate the range. So right, just now I mentioned what is the range, the highest and the lowest. And after that you have to click, for example, right, click here. No, you have to click all of the question here, the mean, the variance, and the standard deviations. Alright, so make sure you answer all the questions. Okay, alright, that's all the class for this session. We're gonna proceed after this. Alright, thank you.